We established Threads of Life in 1998 with a fourfold vision. This was to build Indigenous livelihoods, to empower women, to support culture and identity, and to sustain dye plant ecologies. We now work with over 1,000 women in more than 50 communities across 12 Indonesian islands. And we sell these women's natural dyed traditional textiles through our gallery here in Bali and through our website. We're able to work with so many weavers because we make ourselves students of their culture. We don't make them have to understand the global market. We study each community's textiles and we learn what is a great textile by the values of their tradition. We then reflect this understanding back in our quality control work, rather than imposing a foreign aesthetic. And so the weavers always understand how we value their work. And we also get great cultural information that we can share with our customers. In the beginning, our interest in natural dyes was both aesthetic and economic. We liked what the natural dyes looked like, and we could mark up natural dye textiles enough to make a viable business. But when we entered a village asking to see natural dye textiles, and were seen to be paying more for natural dye textiles, weavers would show us anything. It was certainly a case of buyer beware. So we had to learn how to be dyers for 3 reasons. First, we needed to know what we were looking at to make sure that it was really natural dyed. Second, we could talk to a weaver and see if she knew how to use the plant dyes she claimed were in her textiles. And third, knowing how much plant material was needed, we could visit gardens and see if the pile of cloths being sold could be made with the plants available. And in doing this, we learned 2 things. With the government pushing the use of synthetic dyes, there were big problems with the transmission of natural dye knowledge between generations. And with the change from subsistence farming to commodity farming that we were seeing, a diverse landscape was being reduced to a few commercial species. Strangely, they all begin with C: coffee, chocolate, cashews, candlenut, cloves. Initially, we were documenting recipes in the field and testing them with controlled variations in the studio. And over the years, this studio has grown from a research space into a production studio. Indonesian traditional dyes are 3 main colors: black or blue, red, and brown. Blue is from Indigofera tinctoria that grows wild, seasonally with the monsoon, and is harvested between March and May. A weaver will have 1 larger pot for making paste from fresh leaves, and this is used to replenish up to a dozen smaller dye pots. She'll stir up the dye pot and dye in the paste to get a deep blue. Reducing agents are secret, and recipes are handed down from mother to daughter. Dyers will not share their reductor recipes with us, but what we do know is that various woods and barks are used. Where rituals remain, they are around the indigo dye house. Paste is not made and saved, except in Sumba, where the process has been commercialized for a century, so the indigo dye season is limited. Indigo traditions are facing several intersecting crises. One problem is to do with rituals. For example, in Timor, every year, a ritual to reopen the indigo vat accompanies harvest ceremonies. If a year is missed, as happened for many weavers this year, the vat needs reinitiating with a much bigger ceremony. The cost of this rite and the fear of the spirits that have been ignored for a year are prohibitive. To address this, we need to keep purchasing so that there's no break in the dye work. A second issue is knowledge loss. Once the change has been made to synthetic dyes, the change back to natural indigo is difficult. Reteaching is a slow process when there are no indigo dyers left, but is easier when there is at least 1 person to support. A third challenge is dye plant supply. Work stops when indigo plants run out, or the textiles get so pale that they're hard to sell. So in Timor, we're teaching farmers to make paste and teaching weavers how to use the paste. This extends the dyeing season by 6 months, increasing quantity and quality of production and increasing weavers' incomes. In 2000, we were given 4 cuttings of Strobilanthus cusia from Singapore Botanical Gardens. All Strobilanthus plants in Indonesia are cuttings from these cuttings. We promoted Strobilanthus because it grows in woodland shade rather than taking agricultural land, which would undermine food security. And also because these Strobilanthus are infertile and so cannot become invasive. Now as much as 100 hectares are being grown by farmers we have facilitated, mostly in Java. In Flores, we're working with farmers to produce a paste that can be distributed across the Eastern Islands. We're working with the Environmental Bamboo Foundation that has established over 2,000 hectares of bamboo with their partner communities. Their interest in indigo is as a companion crop that can be grown near the bamboo, can be harvested in a few months, and will give farmers a reason to visit and maintain their bamboo stands more often. This region is one of the first areas we started to work in too, with a master weaver called Katarina. She was the lone keeper of the indigo tradition, but her habit of dyeing in the paste and then beating her yarns after drying to remove the lime made the work unappealing to younger women. The problem was that the indigo dye houses were moved from beside a river up to the village in the 1980s. For years, we've been trying to recruit younger weavers to use indigo, and finally persuaded a group that there was a way to dye with indigo that didn't involve breathing lime dust. Muds are used for mud dyeing are typically pink down to about 20 centimeters and then black below this. The pink color is hydrated ferric oxide or rust, which is insoluble and red colored. Below 20 centimeters, the mud is oxygen depleted and iron-reducing bacteria live here by reducing the rust to release the oxygen that they breathe. This produces ferrous oxide, which is soluble and black, and this is what is sought after by mud dyers. When ferrous oxide reacts with tannin, it makes iron tannate, which is a black dye. Traditional dyers therefore pre-dye with a tannin before soaking in mud to dye their textiles black. In the Amanatun area of Timor, mud holes have the characteristic pink mud at the top. The mud is used beside the mud hole for convenience, as in the picture. Harrisonia brownie is the tannin source, and a boiled tea of the leaves is taken to the mud hole for application before each mud dyeing. This work can only be done while the mud hole lasts, at the start of the dry season, and while there is water for the copious washing that is needed. In West Sulawesi, as a textile is depicted here on the right, they have year-round rivers and so can repeat their mud dye work to get a deep black. They use Homolanthus novoginensis as their main tannin source, but the process is the same. Chemically, the traditional process for making red is close to that for madder. The European process was for yarn treated with Turkey red oil, which is sulfated castor oil, and alum, and then dyed with madder root. The Indonesian tradition is for yarn treated with kemiri oil and simplocus bark or leaf, and then dyed with Marinda citrifolia root bark. Sustainable harvesting takes small roots on one side of a tree to a radius of 1 meter each year. Traditionally, a woman would go to a marinda tree and sit at its base with her feet out before her. Knocking on the tree over her shoulder, she would say, "Husband, I've come to take some roots to make the red dye." She'd then dig no further away than her feet were from the tree, and no deeper than a foot below the surface. Since the tree's main roots arc back to the surface about 2 meters from the trunk, this ensured that the tree survived. A 10-year-old tree would produce 5 kilos of root per year by this method. If you cut the tree down and dig up all its roots, you get about 50 kilograms of root. The issue with the red dye is the supply of trees. Where there is a sustainable method, like in Malacca, Timor, where this image was taken and where the textiles in the following slide are from, you get little production. Where there is an unsustainable method, you get radial depletion, as in the following cases. For dyers around Ende on Flores, the price for roots in the local market gets higher and higher, but the market for cloth will not bear a higher price. For dyers in Tenganan on Bali, they've exhausted the supply in Nusa Penida and East Java, and are now looking east to Lombok. From 2005 to 2015, we encouraged weavers to plant more trees, but with little success. Weavers wanted to focus on their textile work, but farmers saw no value in a long-term non-timber tree. As a solution to this issue, we are trialling a method that takes cuttings from good dye trees and grows them out for just 1 year in polybags. If survival rate is increased to 43%, yield will match the traditional method and give an immediate income. With help from agronomists, survival rates can be increased to viable levels. Marindone red dye from morinda tree roots does not bind with the cellulose of cotton. To dye cellulose fibers with morinda roots, an oil mordant and a metallic mordant are needed. The oil mordant is usually made from candle nut oil that has been saponified, that is made into a soap, either by treatment with an alkali or certain plant enzymes. When cotton yarn is soaked in this saponified oil, one end of each molecule binds to the cotton. Allowed to go rancid and dry over several months, the saponified oil combines with oxygen to form an elastic layer around the cotton. When the dye vat is made from morinda root pulp, dry simplocus cotrichinensis leaf powder is added. This contains aluminium, which dissolves into the dye vat. Slowly, over the course of a day, the vat turns from brown to red as the aluminium binds to the saponified oil and the marindone binds to the aluminium. The result is a cellulose, oil, aluminium, marindone chain that dyes the cotton red. Getting the proportions right is critical to efficient use of dye plants. The textiles in the previous couple of slides are from Malacca in Timor. Weavers have always gotten these great colors, but as their access to simplocus dwindled, they used less and less in their recipe and had to dye more and more times. By rebuilding their simplocus supply and showing them proper ratios, they got the same color with many fewer dyings and much less morinda root use. In 2005 and 2006, we organized week-long archipelago weavers festivals for over 100 weavers from across our network. A principal aim of the festivals was the sharing of dye knowledge. We knew everyone regarded their recipes as secret and also knew most had recipe problems. So we gathered everyone in a huge tent and had them all demonstrating their own work on a particular color each day. Each woman was intensely curious about what the others were doing, but realized that nobody would share with them if they didn't share back. Slowly, conversation started, and by the week's end, major sharing was happening. The key was to use our knowledge to set up the right situations and pose the right questions, rather than to tell people where they were going wrong. One of the main issues discussed during facilitated morning sessions was the loba supply used in the red process, and we were asked to find out where the tree was growing, what it was, and how they could get seeds or cuttings to grow. Tradition was for dyers to use loba bark, except in the ND region of Flores where they used only fallen leaf. Though it had lower aluminium content than the leaves, the bark was easier to trade. Dyers would taste it at the market to test if it was what they hoped it was. But bark stripping killed the trees, and this further threatened supplies. By 2000, traditional trade networks were failing, as remaining forests were rightly protected by the Forestry Department. Our research determined that loba was Simplocus cotrichinensis. In eastern Indonesia, simplocus trees favor habitats in old forest above 600 meters elevation. Such woodlands have been significantly reduced in size since the 1970s. by conversion mostly to production systems. What we did is we made wanted posters for farmers across the network. We got many sightings, and some of them were indeed simplocus. We used posters because most of the farmers who would best know the plants were basically illiterate, but they would know what flowers look like, they know what fruit are, and they know what a bark slash would be, what happens to the sap when you cut a tree. From these sightings and from following up on them, we found that the largest easily accessible simplocus stands were along the central mountain ridge of Flores. We worked with the forestry department and 2 villages to set up women's collector groups. These groups pick foreign leaves between August and October each year. The Flores collectors sell us about 1,000 kilograms a year of dry simplocus leaves. Weavers can collect about 1 kilogram of leaf per day by walking through the forest, and we buy this at 30,000 rupiah a kilogram, which is about $2 per kilogram and $2 per day. The price was set to match the income per day from coffee farming, which is the lowest daily income they already work for. But they don't make this every day, so the simplocus work was supplementary income, not replacement income, and therefore was welcomed. And this flags a key issue. What we needed to do first was make the supply chain work as a business. Once the business works, then we can increase what we pay. Soga brown is the principal dye of Central Javanese batik. The dye is made of Peltophorum pterocarpum bark, Chiriops tagal bark, and mcclure cochinensis heartwood. The Peltophorum is a forest tree and not problematic. The Chiriops and the mcclure are different stories. Chiriops tagal is a mangrove, and mangrove forests are endangered. Mangroves are important carbon stores. They stop coastal erosion, and they are the nurseries for pelagic fish. Chiriops bark makes a beautiful rust brown dye, but highlights that using natural dyes is not automatically better for the planet. So we were very excited to find Indonesia's only Forest Stewardship Council certified responsible mangrove concession at Bintuni Bay in West Papua. At Bintuni Bay, Chiriops tagal bark is a byproduct of timber harvesting and is processed into an extract by communities around the forest. Mcclure cochinensis is a climber, and its heartwood is the most prized yellow dye in Indonesia. Once used to paint tiny highlights on Sumbinese Hingi textiles, by the 1990s it was being used to dye whole cloths for the tourist market. McClure demand had already increased 6-fold during the New Order period of President Suharto from 1965 to 1998. This was because the soga dye recipe in Javanese batik became more yellow to reflect the colours of Suharto's political party. By 1990, mcclure had been harvested to commercial extinction in Timor. The only place that did not sell its mcclure was the village of Boti, where customary law protected the land from exploitation. But even here, mcclure had become endangered. This was because cattle were introduced in the 60s and 70s to replace water buffalo. And while the buffalo never strayed far from water, the cows wandered everywhere. When we performed a botanical survey in 2018, we saw the impact of the cattle firsthand. The mcclure population had a missing middle. There are small plants that have not yet been browsed or trampled, and old plants that were big enough to survive when the cattle arrived. Farmers will not plant mcclure as a dye plant as it takes too long to harvest, pays too little, and because of the long, sharp spines. But another mcclure species, Mcclure pomifera, or osage, was used as a dye and a living fence in the United States during the 19th century. Mcclure is a vigorous sprouter and will strike from a cutting, if it can be watered through Timor's harsh dry season, So maclure spines can solve the short-term problem of roaming cattle, and we are working with the customary leaders of the village, planting maclure to enrich dilapidated fence lines and contain the cattle. In the long term, this can also solve the dye supply problem by harvesting from these fence lines. Success for Threads of Life has meant developing many skills, and the COVID pandemic is testing our business survival skills to the limit. But with support like that which we are receiving today from Botanical Colours, we feel confident we'll get through this. We now rely on our website and mailing list for sales, so please visit the website and sign up for our bi-weekly newsletter. Our gallery in Bali was closed for 15 months and has just reopened, though to a trickle of visitors. We've not been able to visit many weavers, and we don't know how many will have left their looms by the time we get back to them. Weavers who are working have not been able to get any yarn other than that which we can supply them. We've moved all our marketing online and are rebuilding our website, so please have a look and see if there are any of these beautiful textiles that would enhance your home. For the trunk show that we're holding after the Q&A session, a special page has been set up for the textiles we will show. I hope you can stay for this. Thank you to Kathy and Amy for organising this event and supporting our work, and thank you all for coming to today.